How big is the universe? Where does it begin and how far does it go? These are questions that we have surely asked ourselves at some point in our lives, without ever having a concrete answer. The distances in the cosmos are exaggeratedly incredible, so much so that they are escaping our logical comprehension. Thanks to the current advanced technology in astronomical matters, we can get a tiny idea of all the distances and sizes that some impressive objects in the cosmos can reach, making it an endless place where only the most extensive imagination could describe. In spite of not having a solid answer about the size of the universe, some scientists think that there could exist an infinity of universes outside our own with unique characteristics and governed by their own laws, as well as beings that we would never expect to observe even in the depths of our imagination. What we are sure of is the size of the objects that abound in our universe, and recently NASA scientists, with the help of our legendary James Webb Telescope, have discovered the most gigantic structure ever discovered. So stay with us to discover this new discovery by the James Webb Space Telescope, and remember to like and subscribe, it helps us a lot. To give you an idea of the colossal objects and structures that abound in the cosmos, it is necessary to start at the beginning. Our moon measures approximately 3,474 kilometers in diameter, but it is a small sphere compared to our planet Earth, which has a diameter of 12,742 kilometers. If we compare it with the largest planet in our solar system, it would look like a ping pong ball in front of a soccer ball, which would be Jupiter, with a diameter of approximately 400,000 kilometers. Now, let's compare Jupiter with the largest planet in the known universe, HD 10546b, a gigantic planet 7 times larger than Jupiter, with a total diameter of 986,000 kilometers. You can imagine what Earth would look like near this cosmic monster, can't you? However, although the latter has the title of the most gigantic planet in the universe, it cannot compare with the size of our Sun of about 1,382 million kilometers. Even our Sun would also look small if we compare it with the largest star in the universe. This is Stephenson 218, a red supergiant of about 9,000 million kilometers, which looks like this in front of our star, something really spectacular. Not everything ends here. This star cannot be compared with the most massive black hole in our cosmos, the TON 618, an incredible object that has approximately 600 billion solar masses and a diameter of 390 billion kilometers. For now, we will stop measuring in kilometers and start measuring in light years. If you thought the largest black hole in the universe was spectacular, it cannot compare with the enormous size of the Tarantula Nebula, which is the most gigantic nebula in the vast universe, with a diameter approximately of 1,862 light years. It is dwarfed by the size of our galaxy, which spans some 105,700 light years. Much to our chagrin, it is dwarfed by the IC 1101, which spans 6 million light years, making it the most gigantic galaxy in the entire universe. Plunging into the vastness of space, there are even more colossal objects that could degrade the largest galaxy in the cosmos. Here is the Great Void of Eridanus, a region of the universe in which there are no galaxies or any known object, and measures the exorbitant figure of 1,800 million light years. However, this object is small compared to the Great Wall of Hercules Corona Borealis, with 10 billion light years in diameter, or what would be 11% of the observable universe. Although some specialists claim that this is the largest object or structure in the known universe, there are those who do not overlook the most monstrous object in the cosmos, the universal fabric or cosmic web, with approximately the entire magnitude of the observable universe. This object has been recreated by computer from a rigorous scientific study resulting in the impressive image you see on screen, where everything seems to be connected as a kind of neutral system, giving life to a biological entity, and perhaps the universe in which we live is a kind of intelligent life. A team of scientists from the University of Bologna has compared two of the most complex systems in nature, the neural network of our brain and the cosmic web of galaxies in the universe. What did they discover? That they are incredibly similar. And not just as they look if we compare a human neuron with a cluster of galaxies. There's more. The study, which aimed to look beyond the visual similarities between the human brain and the cosmic web, the structure of filaments, nodes, and voids that form galaxies, do the two have a deeper connection? A priori, neurons and galaxies are very different, but this research published in the journal Frontiers in Physics suggests that they are shaped by similar underlying principles. Thus, it is not that our brain is like a universe or that the universe is a brain of titanic proportions, but that their dynamics are similar. Within both systems, only 30% of the masses are composed of galaxies and neurons. In both, galaxies and neurons are organized in long filaments and nodes between filaments. Finally, within both systems, 70% of the mass or energy distribution is composed of components that play an apparently passive role, water in the brain and dark energy in the observable universe. Despite having a scale difference of approximately 7 times orders of magnitude, the brain and the cosmic web composition show similar levels of complexity and self-organization. Our analysis showed that the distribution of fluctuation within the neutral network of the cerebellum on a scale of 1 micrometer to 0.1 millimeters follows the same progression as the distribution of matter in the cosmic web, commented one of the researchers in charge of this project. When we hear that everything is connected and that we are all influenced by each other, it probably has a lot to do with what you have just heard. The actions we take and the actions we don't take create destiny and reality. Together we form a universal system that flows endlessly. In fact, that is why it's called the universe, because together we form a unity. The idea that everything is connected and that our actions have an impact on the world around us is a concept deeply rooted in many philosophies, spiritual beliefs, and systems of thought. This notion reflects the interconnectedness of all beings and phenomena in the universe and can be found in various cultures throughout history. The idea that everything is connected and that our actions have an impact on the world around us is a concept deeply rooted in many philosophies, spiritual beliefs, and systems of thought. This notion reflects the interconnectedness of all beings and phenomena in the universe and can be found in various cultures throughout history. The idea that everything is connected is based on the premise that we live in an interdependent universe, where every action and choice we make has an effect on the every fabric of reality. This implies that our individual decisions, whether large or small, contribute to the development and evolution of the world as a whole. If we make conscious and positive choices, we can contribute to positive change in our own lives and in the lives of others. The notion that we are part of a universal system aligns with the idea that all beings and objects in the universe are connected in a complex web of relationships. From a scientific perspective, this can be seen in the interplay of physical forces and natural laws that govern the workings of the cosmos. From a more spiritual or philosophical perspective, this implies that our individual lives are intertwined and intricately connected, and our actions have consequences that extend beyond what we can directly perceive. In short, the idea that everything is connected and that we form a universal system invites us to be aware of our choices and actions, recognizing that our destiny and the reality we experience are influenced by our active participation in this interconnected web. This can inspire us to make more informed and responsive decisions, contributing to a better and more harmonious world for all. Thanks to the groundbreaking and revolutionary James Webb Space Telescope, we are about to unveil 5 stunning new images that redefine the boundaries of space exploration. Get ready, because the universe is much more intriguing since the James Webb is sending us images. Remember to like the video and subscribe if you're not already. We start with the enigmatic galaxy ANGC 548. In the vastness of the cosmos, we often observe galaxies that follow recognizable patterns. However, have you ever come across one that breaks from the norm? This is where the ANGC 548 galaxy comes in, a galaxy that refuses to fit the typical descriptions. ANGC 548, located in the constellation Centaurus, was initially cataloged as a planetary nebula by English polymath John Herschel in June 1834. But there was a twist in the tale. For a long time, astronomers considered it a planetary nebula, which is essentially a glowing envelope of gas and dust created by an ancient dying star. However, ANGC 548 later revealed its true identity as an irregular galaxy located approximately 16 million light-years from our planet. If you're wondering what a light-year is, it is the distance light travels in 1 year. So, when we say that ANGC 548 is 16 million light-years away, we imagine the vastness of space that light has had to cross for 16 million years to get from ANGC 548 to Earth. ANGC 548 harbors a mysterious entity called ANGC 548X1, which is no ordinary celestial object. It is an ultra-luminous X-ray object which could be compared to a cosmic lighthouse emitting a massive X-ray burst. These sources are incredibly rare and intriguing to scientists, and astrophysicists speculate that they may hide intermediate mass black holes. With the unique shape of ANGC 548 and its possible connection to intermediate mass black holes, it is not surprising that this galaxy has puzzled and fascinated astronomers for nearly 2 centuries. It is a true cosmic rebel that challenges our understanding and invites us to explore the wondrous mysteries of the vast universe. Image number 2. The glowing core of ANGC 2217. The glowing heart of ANGC 2217 is a celestial enigma that immerses us in the wonders of space. This galaxy is nestled in the constellation Canis Major, a staggering 65 million light-years from Earth. To put it in perspective, the light we are seeing today began its journey at a time when the dinosaurs roamed our planet. ANGC 2217 is no ordinary galaxy. It is a barred spiral galaxy. When we speak of a bar in this context, we do not mean a long straight object made of metal or wood, but a structure formed by countless densely packed stars that emit light, creating a bright central band. This galaxy is comparable in size to our own Milky Way galaxy, stretching approximately 100,000 light-years from one end to the other. Imagine undertaking a journey across such an expanse. It would be a journey that would take a long time. So why is this central bar in ANGC 2217 relevant? Well, in galaxies like this one, the bar acts as a sort of conveyor belt that guides and funnels gas from the outer regions of the disk into the galaxy's core. Once there, the gas and dust have 2 main fates. Some coalesces under the influence of gravity to give rise to new stars, further enriching the galaxy's stellar population. Meanwhile, others have a different fate. They are attracted by the giant lurking at the center of the galaxy, a supermassive black hole. In the grand scheme of the universe, ANGC 2217 represents a shining example of how galaxies evolve and transform, driven by their internal dynamics and the colossal forces at work in their cores. This glowing core is a mesmerizing reminder of the complex dance of stars, gas, and dust that unfolds millions of years away but interwoven into the vast tapestry of the cosmos. Image number 3. Luminous stars in the cosmic weave. Imagine pouring a pinch of salt onto a dark canvas, where each grain glows with its own light. This is the stunning visual display provided by NGC 1755, an open star cluster that unfolds before our eyes through the lens of the James Webb Space Telescope. This dazzling cluster is anchored in the constellation of El Dorado. With its deep gaze, the James Webb Space Telescope has delved into the heart of NGC 1755 with the goal of unraveling the intriguing mystery of the coexistence of stars in this cluster. When we talk about a population of stars, we mean a group of stars that share common characteristics, such as age or chemical composition. Just as people of the same age may share experiences or cultural references, stars of similar populations can provide a collective narrative about their origin and evolution. Understanding these populations in clusters like NGC 1755 gives astronomers a chance to have a front row seat to the grand theater of stellar evolution. Star clusters are like time capsules that preserve the histories of stars past, present, and future. Given the proximity to our own Milky Way, these star clusters stand as excellent cosmic classrooms for the purpose of exploring and learning in this vast universe. NGC 55 and its luminous stars stand as storytellers who, through their past, present, and future histories, provide us with a constantly evolving view, demonstrating that there is always more to discover, even in the tiniest sprinkling of stars. Image number 4. A stellar dance among galaxies. In the vastness of space, galaxies are not isolated entities. Sometimes, they come so close together that they begin a cosmic dance, influencing each other due to the gravitational forces that hold them together. This phenomenon is vividly illustrated in the image of ARP 273, a pair of galaxies located at a distance of 300 million light-years in the Andromeda Galaxy. The larger galaxy of this duo has a peculiar distorted and contorted silhouette, as if someone had left footprints in the sand. In the case of ARP 273, the smaller galaxy ventured so close to its larger companion that it passed directly through it. You can imagine two cosmic entities so immense and powerful that one goes right through the heart of the other. What happens when two galaxies intersect in this way? Imagine throwing a pebble into a calm pond and the ripples propagating outward. This is similar to the gravitational perturbations caused in the larger galaxy by the smaller galaxy. This phenomenon is known as a tidal interaction, where the gravity of a smaller body, such as the smaller galaxy in ARP 273, influences a larger body, reshaping it in the process. It is fascinating how even on cosmic scales, entities can influence and modify each other's shape. These interactions offers us insight into the dynamic nature of our universe, where there are still countless evolutionary histories of galaxies waiting to be discovered. Each of these galaxies' interaction events unravels a little more of the vast tapestry of celestial tales waiting to be told in the universe. Image number 5. Deciphering the heart of our galaxy. As we venture into the heart of our galaxy, the Milky Way, we encounter an infrared mosaic that defies our ordinary perception. This intricate infrared composite image unfolds the central core of our galaxy, revealing secrets previously hidden from our eyes. The mosaic is a fusion of colors representing different temperatures and elements, illuminating a region that spans more than 300 light-years. Why is this part of our galaxy so significant? In these cosmic confines, a new population of massive stars is found, and these are no ordinary stars. They are titans that harbor immense energy and exert a profound influence on their environment. What has this vivid picture revealed? The interactions and behaviors observed in this central region provides crucial clues to scientists about the birth and tumultuous interactions of massive stars. Imagine being able to peer into the inner workings of nature's stellar factories from our cosmic vantage point. But this awe is not limited to just the Milky Way, as this infrared image offers a window into a local laboratory. When astronomers look at the fiery central regions of distant galaxies, they can compare their observations to what they witness at the center of the Milky Way. This helps them draw conclusions and theories about how massive stars form and how they often come to an end in dramatic explosion in galaxies far, far away. Located about 25,000 light-years away from us in the constellation Sagittarius, this center is not simply a dot in space. It is a testament to the dynamism and complexity of galaxies. With each new observation, especially those as detailed as this one, we come ever closer to unraveling the mysteries of our universe. Imagine the wonders that could be lurking in the heart of the Milky Way, waiting to be revealed. We hope these stunning images from the James Webb Space Telescope mesmerize you as much as they do us. Get ready to embark on an amazing cosmic journey where we will take you through the far reaches of our universe. Be sure to fasten your seatbelt and join us as we explore the mysteries of our cosmos, guided by the exceptional lens of the James Webb Space Telescope. From the fascinating dances of spiral galaxies to the stories hidden in ancient star clusters, we'll dive into some of the universe's most captivating enigmas, including the search for an elusive supernova. If you've ever wondered about the secrets hidden in the night sky, this is your chance to discover them. Just hit the like button and subscribe button and venture with us into the final frontier. In the first image, we see the enigmatic dance of HH 211. In the stellar nursery, located a staggering 1,000 light-years away in the constellation Perseus, NASA's James Webb Space Telescope gives us a fascinating view. It captures an intimate image of the young stellar object known as HARO 211, also known as HH 211, which resembles a celestial baby. What makes HH 211 so special is that it allows us to observe the turbulent early years of a star, acting as the younger sibling of our own solar system. Images captured by the James Webb reveal striking bow shocks in two directions. These bow shocks are the result of a bipolar source of energy at the center of this ripple effect. When viewed through the telescope, these images are not limited to showing molecules such as molecular hydrogen, carbon monoxide, and silicon monoxide. What is exciting lies in the turbulent conditions surrounding these molecules, as they absorb and emit infrared light, which is invisible to our eyes, but detectable by specialized instruments such as the James Webb Space Telescope. This infrared light allows astronomers to trace the complex structure of energetic flows and gain a better understanding of the violent but amazing life of stars, such as HH 211. This information is crucial for unraveling the life cycles of celestial bodies, including our own sun. Could the investigation of HH 211 provide clues to the secrets of our cosmic neighbor's youth? Only time and a telescope exploring the depths of the universe will reveal it. In image number 2, we can observe the intriguing history of AGC 1309. Let's delve into the fascinating narrative of AGC 1309, a spiral galaxy that offers us a celestial vision that immobilizes a moment in time. This galaxy lies at a staggering 100 million light-years away in the constellation Eridanus, standing out like a jewel in the sublime scenery of the cosmos. Beyond its captivating spiral shape and intricate arms, AGC 1309 is the scene of a unique cosmic drama, starring an IAC-type supernova known as supernova 2012Z. At first glance, AGC 1309 might appear just to be another swirling collection of stars and gas, but inside, it treasures the remnant of a spectacular cosmic explosion. What makes an IAC-type supernova, such as supernova 2012Z, so special? Simply put, not all supernovae are identical. They are like snowflakes, each within its own uniqueness. AIC-type supernovae are considered the lighter versions compared to their more common and luminous counterparts. These red events do not completely annihilate the star, but leave behind remnants that enrich our knowledge of stellar evolution. The question arises as to why this unusual supernova occurred in NGC 1309. These are unknowns captivate astronomers as they contribute to deepening our understanding of how stars culminate their lives. Understanding the end of a star sheds light on cosmic creation and destruction, the opposite but interdependent aspects of the universe. Supernova 2012 Zia in the annotated image of NGC 1309 is like a side note in the vast book of the cosmos, a distinctive touch in the spiral frame of the galaxy that communicates to us that something out of the ordinary happened here. The next time you contemplate the broad canvas of the universe, consider NGC 1309 not just as another galaxy in the far reaches of the cosmos, but as a cosmic stage that unfolds wondrous phenomena and eternal questions. In the third image, we observe the majestic Hyades star cluster. Imagine looking through a cosmic telescope at a star cluster that seems to be at an astonishingly close distance. From an astronomical perspective, this star cluster is called the Hyades, located just 150 light-years away in the constellation Taurus. This proximity makes it an object of intense interest for scientists' research, attracting scientists such as J. Ferry of Cambridge University in the United Kingdom. Despite its proximity and being widely studied, the Hyades cluster had jealously guarded its planetary secrets. Until recently, only one planet had been discovered in its interior. Given the large number of stars in this cluster, one would expect it to harbor a large number of planets. This is where the story becomes intriguing. A new study, led by Ferry, revealed a particular phenomenon in the atmosphere of two white dwarfs within this cluster. Although the term white dwarf may sound enigmatic, it actually refers to the remnant of stars that have reached the end of their lives. These white dwarfs are what our sun will eventually become once it has exhausted its fuel and collapsed. What makes the white dwarfs known as WD 0421 plus 162 and WD 0431 plus 126 exceptional is that their atmospheres are contaminated with rocky debris, which resembles cosmic dust swirling around the star. This rocky contamination is of great significance, as it suggests the evidence of asteroids in the cluster. Asteroids are like cosmic building blocks that contribute to planet formation. The presence of asteroids is a promising indication that there could be Earth-sized planets in the process of formation in this nearby cosmic neighborhood. Asteroids play a crucial role in planet creation, acting as the bricks and mortar that assemble larger celestial bodies. Now, watch out for image number 4, as in it, we observe what we have dared to call the heartbeat of a new world. Immerse yourself in the spectacular narrative of the heartbeat of a new world. In the effervescent nucleus of a galaxy, close your eyes for a moment and imagine that you are on the surface of a fictitious planet, located at a great distance. Here, the sky manifests itself as a dazzling spectacle of lights and colors that seem to explode in an intense cosmic dance. What you witness is the awesome and tumultuous center of a young galaxy, lying deep in the early universe. Could this be the epicenter of what in the distant future will become a major galaxy? But what is it that illuminates this firmament so dramatically? In simple terms, conceive of this celestial splendor as a grandiose cosmic fireworks display. However, these are not conventional fireworks, but vast expanses known as nebulae, huge clouds of gas and dust that serve as nurseries for newborn stars. These nebulae glow with the light of stars that are in the process of igniting and beginning their lives. These newborn stars represent life in its earliest stages. while also coexisting with supernovae, which are massive, unstable stars that, upon reaching the end of their life cycle, explode in a spectacular explosion, illuminating the entire galactic environment for a brief instant on the human timescale. These cosmic events can last for weeks on the cosmic timescale. It is impressive to think that something so chaotic and violent can be so dazzling. The galactic core you are observing is evolving rapidly, like the beating of a young cosmic heart. This activity-packed center has the potential to become the epicenter of a future dying galaxy, like the huge elliptical galaxies often found at the center of galaxy clusters. We have saved the best one for last, the awesome hidden jewel of Tarzan 12. Now imagine finding yourself in the backyard of our Milky Way, peering through a telescope of incredible power. Through it, you can capture a slice of our own galaxy, the Milky Way, revealing a captivating scene that occupies roughly the same expanse in the night skies as two full moons placed side by side. Within this cosmic snapshot is a dense congregation of stars so compact that it looks like glittering confetti. You are in Tarzan 12, a marvelous globular star cluster. The fascinating collection of stars lies in the direction of the constellation Sagittarius, at a distance of about 15,000 light-years from Earth. When you look through the telescope, you see a patch of sky dotted with countless stars, all interspersed with thick, dark clouds of cosmic dust. These clouds give rise to complex patterns, looking like ink blots on a background of luminous dots, mainly in the upper right corner of the field of view. In addition, you may notice the presence of a cloud complex called Rufuchi, an intriguing cloud that harbors its own celestial mysteries. However, what is truly intriguing is that the stars in the cluster exhibit a reddish hue in their brightness. What is the phenomenon? The answer lies in the fact that as the light from these stars travels through vast space toward Earth, it encounters cosmic dust particles that scatter the light and give it a reddish, rust-like hue. But there's more. Some of the brightest red stars you observe are not part of Tarzan 12. They are actually age giants considerably more massive than our Sun, and do not necessarily belong to the cluster. They could be considered celestial photobombers that sit in our line of sight, and some of them could be lone travelers wandering the Milky Way without a cluster as a home. Which image struck you the most? I'll read you in the comments. Remember to hit the like button if you liked the video and subscribe to the channel so you don't miss more content like this. See you in the next video.